My name's Douglas Gourlay. I'm joined today with a couple folks from the team that you'll all get to meet and interact with. Brandon Whitelaw, who heads up our cloud organization and focus on developing our cloud business as well as our overall strategy there. Dak Bush, who heads up systems architecture, solutions architecture, systems engineering globally. Steve Phillips is hiding somewhere around here. There he is, way in the back, literally hiding. Steve looks after product and product marketing. Aaron Oshida on the marketing team, and Aaron Passy, who's the founder and chief architect of the company. So today, don't hold back on any difficult, challenging questions, so I can deflect them to one of the people here that knows a lot more about it than myself, okay? It'll be fun to witness, and I promise their answers will be far better and more effective than mine. So I'm gonna give a quick intro to kind of what we're seeing, what's going on, what we're developing, our overall strategy, and then pass over to Brandon and then Dak to really dive into a couple of the more practical and interesting use cases that we're deploying in production today with clients and walk you through that plus some demonstrations of it. And again, let's keep this as interactive as possible because otherwise I'm just gonna be rambling up here and it'd be a lot more fun with, again, a few hard, difficult questions. I might throw out like fun prizes to whoever asks Brandon or Aaron a question that can stump them. Okay, just to make this fun and interesting. Shortest version of this wonderfully marketing fluffy slide is data growth that we're seeing is absolutely unprecedented. I mean, the fact that 15 years ago I was playing with my iPhone and I was lucky to get a 640 by 480 video done, and today I'm getting 4K stereoscopic and HDR with 10-bit depth. It's insane. Couple that with longer term retention policies we're seeing, and then hard disk drives slowing down in areal density, a number of platters that they can cram into a 3.5-inch form factor, SSDs right at the cusp of incrementing with them from a unit economics cost per terabyte perspective. And what we're seeing is that data growth is really for the first time far surpassing the ability for the SSDs and HDDs to absorb it inside a given facility. As we all know about data centers, space is not our constraint. It's largely power. And we see racks now being designed at 100 to 200 kilowatts in large AI applications. We see 20 to 50 kilowatts in general data center applications nowadays. And if you look at the power density often available, or even the lack of power critical infrastructure available to support some of these higher density data center builds, the question becomes, how do we get more out of that facility we have? And a one-time refactoring can sweat the asset a little while. We can go from Intel to AMD Threadrippers to ARM processors and squeeze a little bit more juice out of that data center power budget we have. But we've always been relying on the fact that every 2 years, semiconductor transistor density doubled. And in the same size, weight, power footprint, we could shove double the data in there. But if data is growing faster than your data center's ability to absorb it, you aren't left with a whole lot of choices. Those choices look like build a new data center. Who doesn't love that? Extend to a hosting facility or use a cloud. That's about the only choices that our customers have available to them once they've refactored to be as efficient as they can within a given facility. And how do they absorb this unprecedented data deluge that's coming their way? Plus, the data is increasingly finding ways to be valuable. It's not like we're just harvesting tons of data and storing it for the hell of it. It's data that feeds image recognition systems in medical imaging and PACS systems. It's video surveillance data that some universities say they want to keep for the duration of the statute of limitations for the types of crimes that often occur in campus environments, or jail systems, or police body cams. Or in some cases, we're seeing customers say we have 350 petabytes of data scattered over 8 to 12 research campuses, plus Amazon, plus Azure, plus Google, and 2 data centers. We have interesting proteomic microscopes that generate 750 terabytes of new data a week. And we have to absorb it, and then we have to get all of that data sent over to an AI processing facility that somebody bought in Dallas where power was plentiful. And now they have to get data globally run through this processing facility. And as one of our customers said, really simply, in the data set we store on you is the cure for cancer. We just need you to store it long enough and durably enough and get it to the places it can be processed so we can actually unpack and find it. This is somebody running 100 frame rate or 100 hertz frame rate protein analytics of protein interactions on Petri dishes again and again and again. And that's what they believe is the root cause for metastasizing cancer cells. So it's like amazing challenges in this space of holding this much data, curating it, making it available, and then getting it where it needs to be to do the thing that's most valuable for the business. The other piece is we're seeing a tremendous shift in, hey, people want to use cloud or go on-prem. And there's this incredible myopia in our industry. To pick on Dell for a second, I saw a wonderful post from Michael Dell on LinkedIn a couple weeks ago that said 84% of the people, I might have the number slightly off, there's like 80% of the people that we polled are repatriating workloads from the cloud to on-prem. I don't disagree. I have a book called How to Lie with Statistics. It's a good read. I'll guarantee you that 84% of people are looking at repatriating some workload from the cloud somewhere to on-prem. Just like I looked at the price for my Adobe Lightroom library in the cloud, said it's a little ripping high. Maybe I should go back to storing it on the NAS array at home rather than paying $30 for 3 terabytes a month. Feels like a good economic decision on my part. At the same time, if you're a company that's only in the cloud, what's your myopic echo chamber worldview going to look like? It'll be like some of these analysts I heard in 2008 going, if the answer isn't cloud, the question's wrong. Cloud first. No, cloud only. If you're doing anything on-prem, you're a Luddite. What's wrong with you? I think we know that the hybrid world is really what all of us operate within. There are workloads that make tremendous sense in the cloud. There are workloads that make tremendous sense on-prem. The function of where your applications are, where your data is, where it's generated, where your facilities are, the quality and caliber and breadth of team you have, your facilities capabilities, and so on. If you don't have that, go to the cloud. If you do, maybe you should be able to go on-prem. Our point of view is simple. You need the freedom of choice. You need to be able to, our job is basically eliminate as many technology barriers as possible. So our customers can use cloud if it's the right business decision, and use on-prem if it's the right business decision. But historically, cloud was a difficult business decision for file because the price was $150 per terabyte per month versus 4 to 8 on-prem. If we can normalize the unit economics, now it can be a practical business decision without technology barriers to determining what the right place for your workloads are, what the right place for your data is. And that affords capability to the business that simply wasn't there before. So our strategy became first run anywhere. And run anywhere is x86 or AMD or ARM, server vendors of Cisco, Dell, Fujitsu, HPE, Supermicro, Arrow, your choice. This solves supply chain issues. This gives you better competition amongst vendors for hardware platforms, and it lets you determine which hardware platform best suits your requirements. But I had a large global bank, as we were talking about qualifying. I said, well, it'll be 9 months to qualify your platform. And that's the usual answer you'd hear because you have to test the attack surface, the crypto boundary, get these appliances all connected into the tooling that they have, their CMDB, their ITSM, their vulnerability management. I said, no. We're an RPM. We can load as a RPM or DEB. We can load on your existing Linux build you've tested and certified already across the firm. I mean, it works with every ITSM, every CMDB, all the tooling the enterprise has built doesn't need to be retooled to work with the platform. And the result was, oh, well, that'll be 30 days qualification then, not 9 months. They like that. But from our customers' business and not having new customized tooling to integrate yet a new vendor into their environment, great simplification. Part of run anywhere is run on any cloud. Amazon, Azure today with our cloud native variant, and we're going to extend that over multiple clouds in the very near-term future. And this is a cloud native implementation that Brandon will talk a lot about, which is how we compress those unit economics down. Enabling data to be everywhere. It's like that movie line or that movie title, Everything, Everywhere, All at Once. Very weird film. Right? Very weird. One of the strangest films I've seen in recent memory. But having your data everywhere you need it, instantaneously. Building a global namespace that's strictly consistent, that allows for ensuring that the doctor gets the latest PACS images when they're looking at the client, that we're enabling global replication and global streaming of the blocks of data that are relevant in a follow the sun editorial cycle in the media and entertainment world, or enabling, national intelligence community collection worldwide, and also with streaming out GIS data and Esri data and so on in the engineering world. Making that data available everywhere, ubiquitously and consistently, is a tremendous challenge, especially when you look at overlay global namespace products that don't have the low-level verbs to guarantee strict consistency. That's how you get data loss. You have to verify the data is durably written before you accept it and let everyone else know that that data is now available. And then this is a systems problem, right? If you think about what we just described, it's a storage problem, it's a compute problem, it's a networking problem, it's a wide area and local area optimization problem, it's feeding GPU farms, it's all of these workflows and workloads working together. Network attached storage is a wonderful 1990s era construct. Shouldn't it become network aware? We're synchronizing data from one location to another. I had a customer last week, 2.5 petabytes in a data center in Phoenix. They need to get it to a data center in Raleigh. They have a 10 gig link. The link is reasonably utilized by other applications throughout the day. Quick math question. How long do you think it takes to replicate 2.5 petabytes?
Months. A truck ride.
Depends.
A plane ride.
A truck ride is an
A
answer.
drone ride.
Those are all
I
faster.
can continue.
About 780 days
Yeah.
in their scenario. The effective throughput's less than 3 gigs when you have 1/1000th of 1% loss on that bandwidth delay product. Some of the technologies we're working on accelerate that dramatically to less than 90 days. You're talking almost an order of magnitude performance improvement. And if that enables to feed that AI processing center the data from a globally distributed 350 petabytes, that if that finds that cure for that disease they're researching faster, or that it identifies images of a patient record and gives them more determinism and lower risk probability, it wins for everyone. So when you look at our vision, strategy, and how we're executing on it, we started with build out a scale out shared nothing file system. Simple, easy to use, auto clustering, works with existing networks, works with Ethernet, very straightforward. The follow-on evolution has been about building the features and capabilities to be the primary storage system for enterprise unstructured data. There's a litany of features we're all familiar with that just have to be delivered, that every customer has the one thing they need, and unless you have all of the one things they need, you're not ready for prime time. So we spent the better part of a decade enhancing our feature set to be capable of supporting the operational requirements of today's largest enterprises. Then, where we're at today, the announcement of our global namespace, generally available, read-only, read-write, right around the corner. The run anywhere model, edge, core, cloud, multi-platform, multi-server vendor, solving supply chain issues. The cloud native implementation, flattening the unit economics between on-prem and cloud. Intelligent cache manager, which delivers over a 90% read cache hit rate, massively compressing down the costs in the cloud when you have to pay per API call, but also dramatically improving the performance in any AI type application where we have to rapidly serve the data, and there's an iteration of that data again and again and again fed through the pipeline. And then natively integrating with retrieval augmented generation AI system, taking folder at a time, directory structure at a time, and connecting that up through vector databases to Copilot or OpenAI or Grok, making it so easy for our customers to utilize their data in advanced AI models, most importantly, without their data becoming part of that AI model in its next iteration. So it's protecting the customer's data from the model while enabling what most of our enterprises will see, the constructive use of open source or commercially available generative AI models, as opposed to enterprises realistically building their own AI models. There's a fun statistic Brandon sent me yesterday, I think it was. What was the number, Brandon? Number 15? The 15th largest consumer of enterprise H100s has 254 of them in production. The 15th largest. It means you have a very, very short long tail, right? There's a tremendous amount of consolidation in the companies and organizations that have the human capital to build their own models and train them. Nation states, big financial hedge funds that make money on it, large tech alphas that are doing ad serving and interesting things, and hyperscalers. You go off that list, you're down to number 15 with 250 GPUs. Right? The training market is a myth. It's a handful of customers with tremendous concentration. When I have got the largest banks in America saying we have less than 10 to 12 GPUs, we don't know what to do with them yet, we're just kicking the tires, they're not going to build their own model. They're going to use Claude. They're going to use Anthropic. They're going to use OpenAI. And all of those consume unstructured data like it's nobody's business. It's our job and our business to get that data to those models. Where do we go from there? Building out this concept of a global data fabric. It's not just GNS. It's GNS with strict consistency, with network performance enhancements that allow us to synchronize data over these long-haul infrastructures more effectively and efficiently. It's supporting over time, not just unstructured data, but structured as well, allowing a myriad of workloads, enhancing the value of the system. There are workloads and workflows that benefit from block, much as file system people look down at block and go, okay, little brother, that's cool. There's value there. There's workloads that benefit. VM hosting, right? When we look at evolving from there, you don't just want to do deduplication or throw compression at a problem to give the false sense of value. Can we do global deduplication? Not within a node, not within a cluster, but across the entire enterprise. Can we couple that with the ITSM to know which workloads and workflows are critical? We know which users are authenticating, which machine users and applications are authenticating into the system. We know which files and directories are dependent on. And then the replication and data security and provenance policies can follow that particular workflow and workload, wherever that data is. So we don't need 16 or 20 copies. Some scenarios you reduce to 1. Some scenarios you reduce to 3. Sometimes those 3 need to be geographically distributed across different cloud providers and different on-prem environments. That needs to be automated. That needs to be like the network and the system and the storage all playing Tetris with itself. Stack those colored blocks the right place and ensure that everything is in its best location, it's the most available, and it's economically viable in its storage medium and storage selection as well.